Right, we're going to take a look at this reed type transmitter and try and show you some of the functionality of it. So let's switch on. Now these OLED screens often don't show up very well on video. Maybe that'll be okay. So here's the basic screen. We can see that the model that's loaded is number 5 Sawdust. It's showing transmitter battery voltage of 7.7 volts. The little sort of square blocks over on the left side show the positions of the sticks and so on. So if I move this one, you can see a little round dot moves to show where the stick is. The vertical bars moving to show where the servos is. Obviously the servo is slowed down in relation to the stick, and there's also a little triangular thing. I'll just move some of the others. You can move obviously several at the same time. And this is the motor control here, so you can see this one is doesn't return to the center. The bar showing the motor position stays where it is when you let go. Now there's also a trim on this, which is this, just zoom out a little bit, this red button. Now if we press the trim button, then the controls work the trim, and you can see there's also a little there's a little triangle moving. I don't know if you can see there. I'll just tighten up a bit so you can perhaps see it better. We can get this camera to focus. Come on camera, focus. Maybe that's okay. Now you see there's a longer bleep at the centre and so on. It's like any modern proportional set really in that regard. So now let's start looking at the other things. There's a couple of timers there. You can see we've got timer 1, which is currently showing 3:22, and underneath that there's timer 2, which is showing 1:30 and counting down. Now the reasons for that is timer 1 is currently working off the motor, off the throttle. Whenever the throttle is above 10%, timer 1 runs, and we'll hear some bleeps eventually when it gets down to sort of 30 seconds and less, to warn us that we're perhaps running out of battery. So that's appropriate for a electric powered model where the motor run time is the thing that you really want to measure and warn you about. If I turn this encoder around, you can see we move to different things on the screen. It's highlighting monitor there. If I press that, we get some bar graphs now showing the servo outputs. But I'll come back to that in a bit. Notice next to the timers there is an S and an R for set and reset. There are different sorts of timers, and some of them are manual ones that you have to start and stop. They don't work automatically off the throttle like the one timer 1 currently is. And timer 2 is currently a type that starts the first time you use the throttle but then keeps running anyway. The idea being that that will time your whole flight. It starts automatically first time you use the motor and then keep running afterwards. But I can reset it if I go on to R for that timer 2 and press the encoder. You'll see it's gone back to 0. And this is generally the way all the menus work. You highlight the one you're interested in by turning the encoder around, and then press it to get the function that's highlighted. So as I say, that's a microsecond monitor, and you can see when I move the sticks, you can see where the outputs are. Sorry, that's a percent monitor. And there's another page that shows exactly the same thing, but it shows the microseconds from the pulse train going out to the receiver. Now to the main menu. Let's run through these items. We press that, we get the main menu. You can see at default it says main page at the top, which would take us back to where we started. And then the other options are select a model, change the model settings, copy the current model, or the sort of global setting for the transmitters. Let's go back to the main page just for a moment, because I think the timer's getting down to the point where it's about to bleep now. So timer 1, when it gets down to 30 seconds, we're going to hear a bleep, and then we'll hear a sort of countdown series of bleeps for the last 10 seconds or so, I think I did. So we'll get about 5 bleeps when it gets down to the last 10 seconds. So obviously this is telling you time to land. It doesn't keep bleeping after 0, but it just shows negative time. So if you do carry on flying, you can see how much longer than the setting you went for. So now let's go back to the menu, select a model. You can see we've got a bunch of models here. There are 20 available. So if I go for what have we got here? Depron Birdie. It's now loaded up Model 3 Depron Birdie instead of Sawdust, I think I was on before. I'll go back to Sawdust for now. If we want to change the name, we go into model settings, and if the first thing is model name. So again, turning the encoder selects the position, get to the one you want to change, press it. Now we can go through all the available different characters. So let's say this was going to be Sawdust 2 or something. There we are, we've done that. And we've finished now, so back to model settings. Timers, it's what I talked about before. At the top you can see we've got a throttle greater than 10% down timer with a 3.5 minute duration, and a timer 2 is a 10% greater than. On the throttle starts it and it's silent, there's no bleeps. But I'll show you the different ones that are available. So if we go onto there, select, we can see we've got off, so it just doesn't work at all. A manual down timer, one work by the throttle. A manual up timer, again one work by the throttle. A manual one that's silent. And that's the start silent that we were on originally. Those are, oh, and since model chosen, that's just since you switched the transmitter on or since you last chose a model, how much time's elapsed since then. Next thing, servo speeds. There are two sorts of simulated servos: the normal servos that you'd have on all the main controls, which back in the day, the what were they called, Bonner Duramites, used to take about a second or so to go from the centre to the end, or a total travel about a second. You can see at the moment I've got it set to 1.5 seconds, but you can set this per model to suit your flying style. And then there were progressive servos which you went on the throttle and on the elevator trim back in the day, and they were typically about half as fast and again you can alter it, but we can go up to 5 seconds if we want to, or whatever, again whatever you think's appropriate for the way you fly. Let's put it back on 3 for now. Trim ranges. There's two sorts of trims. There's the reed elevator trim, worked by the dedicated reed switch. You can say how much range you want that to have. At the moment it's 20% of the full range. And there's also the one I showed you where you press the red button and use the normal sticks and it beeps, sort of more conventional trims. And again, you could set the range to that for 10%, 20, 30, whatever you think's. It depends how much trim your models need, I suppose. You could switch it to 0, of course, if you want to disable the trims altogether. Back to model settings. Mix a steering source. This sounds a bit complicated, but it's basically saying if you want to mix V-tail or elevons, which of these two steering toggle switches do you want to use? Because different flyers put them in different positions. I think the normal mode is to have your main steering control, which would be ailerons if you had them, or rudder if you haven't got them, on this one, and then the auxiliary one, rudder, on here. But some people have it the other way round. So here, let's say we wanted to set up let's say we were going for elevon mix, so we'd be using the bottom one for that. So we'll change that to bottom, and that's going to be ailerons. The only choices are top and bottom there. And then in channel mixing, this is where we decide which output going to the receiver is driven by which switch or combination of switches. So you can see at the moment we've got for sawdust we've got channels 1 and 6 both doing what was aileron. Channel 2 was elevator, and so on. So for this elevon mix, let's assuming we were doing elevon, we'd want to use maybe 50% of this bottom steering switch plus 50% elevator, and that would go out on the one aileron channel. And then I suppose if you were using elevons, what would normally be your elevator would be the other elevon channel, and that might be 50% bottom minus 50% elevator. So by choosing plus or minus there, with the servo reverse functions that we'll come on to, that covers all the bases. Another option, let's go through them on this unused one. We've got unused, we've got the bottom switch. Normally that would be aileron for most flyers. Top switch would be rudder, throttle, elevator. And then there are a bunch of these mixing ones with different ratios. So you can go 50-50, 60-40, 70-30, and with pluses and minuses to cater for the different options. Oh, servo sweep, let's put that on, and we'll come to that in a bit. I think there's also unused, yeah. We'll leave it on servo sweep for now. So I'm just going to go back to the bar graph monitor for a moment to show you the effect of that. So you can see the servo sweep one sweeping away, and now the first two channels, the last one is still working direct off the switch. You can see it's going to 100% at the moment both ways, but the top two are now going opposite for aileron input, and they're going the same way for elevator input. That's your typical sort of elevon mix. Right, back to model settings, and we've got as far as channel mixing, servo reverse, as you'd expect for each output. You can set it to be either normal or reverse. Simple as that. Next one, endpoints. So for each servo, these are what you call ATVs by some manufacturers. You can set a sort of left and right or up and down travel limit. These are all on 100% on the Sawdust because it was sort of mechanically adjusted to suit 100%. But if your what are we saying? If your elevons were too fierce, you could just wind this down to, I don't know, 50% or whatever, and maybe 50% one way, and you can go up to 125%, but maybe it would be 50 one way and 65 the other or something. Obviously, you set that after you've, well, maybe you set it up to avoid them binding before the flight, but you then adjust them based on flights to give you the throws you want. Sub-trim, this is just an offset. It's a typical thing on modern transmitters, partly for modelers who are lazy, who don't want to twiddle the clevises around on their planes to set things, but also it's sometimes it's useful if you need a control to go a long way one way and not so much the other, like a flap. You can put an offset in before you even start. And this lets you go up to 50% plus or minus of the throw that you've set in the end limit controls. Telemetry. At the moment there isn't any telemetry coming from this thing because I haven't got a receiver plugged in. But I'll plug a receiver in now and we'll see some telemetry start to arrive. Right, well that's going to be a pretty strong RSSI because the receiver's right up close to the transmitter. But we can see now there's a RSSI signal and there's these two analog values, A1 and A2 as they're called by FreeSky. Now there are two things you can adjust. The alarm voltage, if that's set to 0, that effectively switches the telemetry off, hides it. So even though this is giving telemetry at the moment, this receiver, if we go back to the main page, there's nothing on there to do with telemetry. I'll go back into telemetry again now. Once I set the alarm voltage, we will start to see telemetry, and we can choose either A2 or A1. I'll just explain that. Normally A1 with FreeSky is the actual receiver voltage, so in an IC plane or a glider that would typically be your battery voltage. A2 is for connecting a power pack. You have to use some dropper resistors to get it down to a normal range. But let's say this was an electric model and we want to use A2. So we twiddle this round here and you can see the model battery voltage up near the top going up and down. So you'd put a voltmeter on your plane, or you know it's a freshly charged battery. We know it's currently 12.6 volts, say, so we'll, I can't go that high with what I've currently got in, but let's say, I don't know, it's a 2-cell battery and it's fully charged at like 8.4 volts or something. We'd set that to be 8.4 and you can see it's now, we set the range to whatever's needed to make the model battery voltage show correctly, basically. Now if you're using A1, that's the receiver one, you just set this to 0 and it's automatically calibrated then, because there's a fixed range for the built-in receiver. And you can see at the moment we're showing 4.9 volts. I'll leave it on using A1. I'll set the alarm voltage. If I set it higher than 4.9, it's going to start bleeping to say, warning, your battery's low. But if we set it to, I don't know, 4.5 or 4.6. Now if we go back to the main page, you can see there's two additional lines of data on the screen there. There's the RSSI, and you get the bleep from the built-in module if that drops low. It gets down to about 40 something, I think, is a low value. And we can see, as well as the transmitter battery voltage of 7.7, we can now also see the model battery voltage 4.9. That's telemetry. I dare say most people probably won't be interested in that. Back to model settings. I think that's covered all those. What else have we got? We've got copy the current model. This is if you want to avoid, you're setting up a similar model, you don't want to do everything from scratch. You just go and pick a new slot and it copies your current one into there. So you can see we're now on Sawdust 2 on the Model 10. And the only other thing that we haven't looked at is transmitter settings, which are very basic really. All they're for is for monitoring the transmitter battery voltage. So again, you set the voltage range to make the displayed battery voltage agree with what you know it to be. So on my transmitter, that requires a voltage range of 10.1 volts, I found, and I can set the alarm voltage to something sensible. I mean, this is a 2-cell LiPo, so maybe 6.5 volts or something would be a suitable one. But again, if that gets too high, we get another sort of bleep to tell us that the transmitter battery voltage is running down. That's about it, I think. Back to the main page. There's an inactivity alarm as well, but we're going to wait 5 minutes to see that, so hardly worth the wait. Well, thanks for watching. Any questions you can put in the comments and I'll try to answer them. Cheers.